Now going to look at some quadratic inequalities. So we've got x squared plus x minus 12 is less than 0. So we can determine this is a quadratic inequality because it's got an x squared and an inequality symbol, so that's definitely a quadratic inequality. The important thing about quadratic inequalities is you must make a sketch. Alright, to solve it you must make a sketch. So let's look at this one. X squared plus x minus 12 is less than 0. So first of all, that I can say it's a positive x squared, therefore it's a U-shaped parabola. I'll then look for the roots, and I'll look for the roots by making the equation equal to 0. So two numbers that multiply together give plus 1, add together give minus 12. So two numbers that multiply give minus 12 and add together give plus 1 is going to be x plus 4 and x minus 3. So that will give me x plus 4 is equal to 0, or x minus 3 is equal to 0. And that means that I've got a root at minus 4 and a root at 3. So I can now sketch what that looks like, a root at minus 4 and a root at 3. The quadratic inequality then said find where it's less than 0. Well, less than 0 means below the x-axis. So it's less than 0 down here. So that is between minus 4 and 3. And we call that a closed interval, which is. Okay, this time we're going to go for solve x squared plus 9x plus 20 is greater than 0. So again, positive x squared, it's a U-shaped parabola. I'll find the roots. X squared plus 9x plus 20 is equal to 0. So two numbers that multiply together give 20, that together give 9, is 4 and 5. So that'll be x plus 4 bracket x plus 5 is equal to 0. X plus 4 is equal to 0, or x plus 5 is equal to 0. Which means I've got a root minus 4 and a root at minus 5. I can now sketch this out. And that would look a bit like that. The question then says, where is the thing greater than 0? So that's above the x-axis, so that's here and here. So that would be x is less than minus 5, or x is greater than minus 4. Okay, the next one we're going to solve 2x squared minus 5x plus 3 is greater than 0. So again, positive x squared, it's a U-shaped parabola. So I'm then going to find the roots by making the thing equal to 0. And whatever method you've got for factorising that, you would use that to get x minus 1 bracket 2x minus 3. Then get a root at x equals 1. And that will be 2x equals 3 and x equals 3 over 2. Now the question's asking where the thing's greater than 0. So we've got a root of 1 and a root of 3 over 2. And it's greater than 0 up here and here. So that's x is less than 1 and x is greater than 3 over 2. Okay, next one, 6 plus 7x minus 3x squared is greater than or equal to 0. So let's put this in a more familiar order first of all. So minus 3x squared plus 7x plus 6. And I'm going to be finding the roots. So make the thing equal to 0. Now it's a negative x squared, so it's going to be an upside down U-shaped parabola. I can then take out a common factor of minus 1 so that it becomes easier to factorise. I can then multiply through by minus, I can then divide through by minus 1, and that will leave me with 3x squared minus 7x minus 6 is equal to 0. I'll then factorise that. So whatever method you've got for factorising that, you go ahead and that will give you 3x plus 2 bracket x minus 3 is equal to 0. I then get 3x plus 2 is equal to 0, or x minus 3 is equal to 0. That'll be 3x equals minus 2, or x is equal to 3. And that will give me x equals minus 2 over 3 and x equals 3. So I'm interested in whether this thing is greater than or equal to 0. Well, first of all, remember that it was a negative x squared, so it's going to be a maximum turning point at minus 2 over 3 and 3 with the roots. So that might look a bit like that. In terms of whether it's greater than or equal to 0, that's above the x-axis. So that's the closed interval between minus 2 over 3 and 3, but also because it's greater than or equal to 0, including those. And that's between and including minus 2 over 3 and 3. That's the final answer.